At 7:08 in the morning on August 13, 1956, a Caterpillar D8 bulldozer pushed its blade into a strip of farmland in St. Charles County, Missouri, and began grading the right-of-way for Interstate 70. The Federal Aid Highway Act had been signed into law 6 weeks earlier. The ink was barely dry. Within days, the Missouri Highway Commission had awarded the first contract, a section of what would become the western edge of a network that no country had ever attempted to build before. By the end of that first day, the cut was underway. By the end of that first year, more than 2,300 miles of new interstate were under construction simultaneously across the United States. What followed was the largest earth-moving operation in human history. 42 billion cubic yards of earth, 2.3 billion tons of cement and crushed rock, 1 billion pounds of explosives. The concrete poured for the original system could have built a wall 9 feet thick and 50 feet high around the equator. The engineers called for 41,000 miles of finished highway, 2 travel lanes in each direction, every lane 12 feet wide, every shoulder 10 feet wide on the right, 4 feet on the left. Overhead clearance sufficient for military convoys. No grade crossings, no traffic signals, no interruptions. From the first blade of the D8 in St. Charles County, Missouri, to the last slip-form pour in the late 1970s, it took more than 20 years to build. It changed the country while it was still being built. Every mile of the Interstate Highway System was built twice, once in the design office and once in the ground. And the specifications that governed each mile were identical from Maine to California. Lane widths, grade maximums, curve radii, bridge clearances, all held to the same standard. The system was built to be a system, not a collection of state roads. Before we go further, if this kind of story matters to you, consider subscribing to the channel. Every video here is built around the systems that actually hold this country together. The power lines, the rail corridors, the infrastructure that most people never think about until it stops working. If that's the kind of documentation you want to keep watching, the subscribe button is how you tell us. And we want to hear from you. Did you work on a transmission line, a railway, a pipeline, a hydroelectric facility? Did a parent or grandparent spend their career maintaining infrastructure like this? Keeping the lights on, keeping the freight moving? Leave it in the comments. These stories belong in this record. Now, back to the system. Before any concrete could be poured, the land had to be shaped. On a rolling terrain project in the Appalachians or the Ozarks, a mile of interstate might require cutting down a ridge by 30 or 40 feet on one side and building up a fill on the other. The cut material had to move, not a short distance and not in small amounts. Caterpillar D8 and D9 bulldozers handled the initial clearing and the rough shaping of the roadbed. The D8's 14A series, produced at Caterpillar's main plant in Peoria, Illinois, generated 155 horsepower and was the workhorse of the interstate cuts. The D9, larger and heavier, served as a push tractor. Its job was to come up behind a loaded scraper and push it up a grade when its own engine wasn't sufficient. The scrapers were where the volume moved. LeTourneau C-pull and D-pull motor scrapers loaded themselves from the cut, carried the earth in a bowl of 12 cubic meters or more, and dumped it on the fill. A good scraper operator could move earth continuously, load, haul, dump, return, in a cycle that covered a quarter mile or more each pass. On a large interstate project in the Midwest, a dozen scrapers working in tandem could move tens of thousands of cubic yards per day. The scale was not incidental. 42 billion cubic yards of earth was the final measure of what this system required. That figure did not account for a single foot of finished pavement, but it was the price of the geometry. the cuts and fills needed to bring a standard profile across a continent that was neither flat nor cooperative. Blasting was necessary wherever rock lay near the surface. Construction of the original system consumed more than 1 billion pounds of explosives. The concrete paving train was the visible machinery of the interstate, the operation that defined what the finished highway actually was. Interstate pavement was not asphalt. The original system was designed in concrete. Portland cement mixed to a precise ratio, placed 12 inches thick on a prepared base course, reinforced with steel rebar on a grid, and finished to a surface tolerance measured in fractions of an inch. The standard for each lane was 12 feet wide. The concrete slab moved no traffic for at least 14 days after placement. The curing time needed to reach design strength. The slip-form paver accomplished what had previously required fixed wooden forms along both sides of the roadway. The machine moved on crawler tracks along guide wires stretched taut ahead of the pour. Concrete was delivered ahead of it by truck or conveyor. As the paver advanced, slowly, at perhaps 20 feet per minute, it spread the concrete, consolidated it with internal vibrators, shaped the cross-section with a fixed steel mold, and extruded a finished slab behind it. Behind the paver, workers placed transverse contraction joints, saw cuts that told the slab where to crack when temperature changes induced stress, preventing random fracture. Then the texture machine followed, dragging a burlap finish across the surface to provide skid resistance. Then the curing compound sprayer sealed the surface against moisture loss. Within a mile of the paving machine, 3 separate follow-on operations were already in progress. Nothing stopped. The men who built the Interstate Highway System did not work for the federal government. Construction was contracted to private firms, thousands of them, from major national contractors to regional earth-moving companies with a dozen machines. The Federal Highway Administration and the state highway departments set the specifications and inspected the work. The contractors built it. A large interstate project might employ 400 men on the ground simultaneously. The earth-moving crews operated the scrapers and dozers in overlapping shifts, and often running from first light to last light to maximize daily yardage. A skilled scraper operator working in tandem with a D9 push tractor understood the geometry of his cut intuitively. The angle of approach, the depth of bowl loading, the grade of the haul route. He had spent years learning the behavior of the machine under different soil conditions. Clay, which loaded cleanly but was heavy. Sandy loam, which loaded fast but spilled at the edges. Rock-blasted material, which was unpredictable. The concrete paving crews worked to a different rhythm. The paving train moved continuously or it moved nothing. Downtime on a slip-form paver cost thousands of dollars per hour in idle concrete deliveries, idle follow-on crews, and hardened material that had to be removed. And the foreman of the paving operation watched the pour with the attention of a surgeon, watching the vibrators, watching the edge slump, watching the surface finish behind the mold. The project engineers moved across the job in pickups, reading grade stakes, signing delivery tickets, writing daily reports that tracked footage paved, cubic yards moved, and days lost to rain. Everything was measured. Everything was counted. The decade between 1956 and 1966 was the construction decade. More than half of the entire interstate network was built in those 10 years. The pace was extraordinary. In the first year alone, the system went from a signed act to 2,300 miles of active construction. Every state had contracts underway. The Highway Trust Fund, fed by the federal gasoline tax and dedicated entirely to highway construction, guaranteed a steady flow of federal dollars to the states on a 90% federal, 10% state cost share basis. There was no debate about financing once construction began. The money came with the lane miles. The geography of those 10 years reads like a list of the continent's engineering challenges. In Pennsylvania, contractors blasted and bored through the Allegheny ridges, cutting grade after grade through sedimentary rock. In Colorado, the Eisenhower Tunnel, at 11,000 feet the highest vehicular tunnel on the American Interstate System, was still years away. But the approach grades through the Rockies were being set. In Louisiana, engineers bridged the Atchafalaya Basin on concrete pile bents that stretched for 18 miles across the swamp. The concrete total for those 10 years was part of the 2.3 billion tons of aggregate that the original system consumed. It moved in ready-mix trucks to paving trains that ran from before sunrise to after dark. By 1966, 40,000 miles of the network remained to be completed. The hard miles, the urban connectors, the mountain passes, the urban freeways that required displacing neighborhoods, were still ahead. When the Interstate Highway System opened, it did not just add a new kind of road. It reorganized the geography of American commerce. Before the interstate, long-haul freight moved primarily by rail. Carload freight, manufactured goods, agricultural products, raw materials traveled from origin to destination in the classification yards that Chicago, Kansas City, and St. Louis had built to manage. Rail was slow in turnaround, expensive in handling, and dependent on where the tracks went. A truck on an interstate could leave a factory loading dock in Detroit and arrive at a distribution terminal in Atlanta without a classification yard, without a transfer, without a crew change. The time and distance relationship that had defined American logistics since the 1850s was compressed overnight. The economic consequences followed immediately. Warehousing moved from rail sidings to highway interchanges. Distribution centers migrated to locations chosen by road access rather than rail proximity. The carload freight that had sustained the Chicago yards began its long decline. Between the late 1950s and the early 1970s, the loose car rail freight traffic that had been the backbone of American inland commerce fell steadily as trucking took the routes the interstate had opened. The interstate also accelerated suburbanization on a scale that the post-war planners had not fully anticipated. By making daily commutes viable at 40 miles or more, the highway system extended the practical boundary of every major American city outward by a generation. It was the largest infrastructure project in human history. Its consequences ran in every direction. The primary construction phase of the Interstate Highway System concluded in the late 1970s, 20 years after the first D8 blade went into the Missouri dirt. What had been built was 46,000 miles of controlled access highway, 62 numbered routes, 54,000 bridges, 104 tunnels. The concrete poured for its surface could circle the equator in a wall 9 feet thick and 50 feet high. The earth moved to build it, 42 billion cubic yards. Would take a line of scrapers running continuously for centuries to move again. The machinery that built it was already obsolete by the time the last mile was poured. The D8 and D9 had been succeeded by larger, hydraulically controlled machines. The slip-form paver had evolved from a machine guided by hand-stretched string lines to one controlled by electronic sensors and laser-leveled grade references. The LeTourneau scraper that had moved earth across the Oklahoma plains in 1958 sat in a museum by 1980. What did not become obsolete was the system itself. Every significant shift in American freight logistics since 1970, the rise of the distribution center, the growth of just-in-time manufacturing, the expansion of retail supply chains, has depended on the network that the D8 operators and the paving train foremen built across 20 years of working ground. They built it to standard. They built it to last. And they built it 1 mile at a time, from the first blade in Missouri to the last pour in the long decade of American construction. If this story gave you a clearer picture of what holds these systems together and what it takes when they come under pressure, subscribe to the channel. There are more corridors, more grids, more operations, and more decisions still to document. And if you have a connection to this kind of work, a relative who spent decades in a control room, a parent who worked a rail yard or a generating station, someone who was there when a system like this was tested, tell us in the comments. What did they operate? Where did they work? What do you remember them saying about the job? The most complete record of how these systems were built and run isn't in any report. It's in the people who were actually there.